Let's move to question C. Right. So we have to employ a certain identity, and we have to re-express a tilde in terms of P tilde, where P tilde is defined in this fashion. It's actually the Fourier transform of the electric dipole moment of the charge distribution. Bring that down. Right. So so we have found the expression for A tilde, the leading order expression for A tilde. Yeah, we're going to use that, even though it's not stated that we have to use the, yeah, we have to use the leading expression for A tilde. We're going to use this thing, right? Also, there's another identity. We write it down. This is now let's work through this thing. We have the leading order term. We have the integral of only j, not the divergence of r I times j tilde. We don't have that. So this is j tilde. My bad. This is j tilde. This has to be j tilde. Yeah, this is j tilde. So let's work with this thing first, like to get this thing, and to like simplify this. So we're gonna use this identity. The divergence of f times v, where both f and v are functions of the covariance, the spatial covariance. So if this is the case, then we have v dot gradient of f plus f times the divergence of v. So if we use that here, we have j tilde, and we have the gradient of ri prime, and we have another thing that is I prime times divergence of j tilde, and this thing is 0. I'm really sorry for the background noise. I have no control over it, as you can understand. I have to work through it. So we have this thing. Now notice one thing, that is this can be written down in terms of rho tilde, right? So we have previously worked this, the relation between the j tilde and rho tilde. So to find it, this thing, right? So we're going to use that. So what we had is we had the divergence and the gradient acting on this thing will and then it's dotted with j tilde I will give you ji omega plus I prime, and this is I omega rho tilde r omega, and this thing is 0. This is r prime. Um, so the 3 r prime. So what we have is we have in the original expression this integral of j tilde, right? So we have that here, j tilde prime. This is nothing but minus r prime, r not r prime, r prime, prime, r I prime, I omega rho tilde omega. Now this is by definition so using the definition, this is I omega times minus I omega times 3 r prime p I tilde r prime omega. Now, so basically this would imply p tilde r prime omega is basically minus I omega prime p tilde r prime omega. Now if we plug this in into the expression, this expression is zoom out a bit. So this comes out to be I omega r by c r. So this thing is minus I omega times sorry, this is not the integral goes away, right? The integral goes away. Integral goes away. Hence we have this. This is a function of omega only, because the r prime is being integrated over it. So yes. I hope that answers question C. Again, I'm really sorry for the background noise. If it's there, I don't know.